Selected, in this video, I'm going to do selected problems from chapter 2 off the study guide. So one of the objectives was to evaluate a piecewise function. So if you had a function like f of x equaled, and there were two rules, they could be anything. One of them might be quadratic, one might be linear, it doesn't matter. And then what happens is they also give you conditions for when those rules are to be used. Okay. All right, so for one of them, we use it when x is less than -3. For the other, we use it when x is bigger than or equal to -3. And then it says just evaluate the piecewise function. So they're talking about you being asked to do something like find f of -2, or find f of -3, or how about f of -1, okay? You get one answer to each of those. So like for f of -2, you don't go plugging it in to both of the rules. You check these conditions first. So you got to think about how -2 is, like think about how negative numbers work. So -2 is actually to the right of -3, so it's bigger than -3. So that means you're going to use the bottom rule, and you're going to plug a -2 in for x on the bottom rule, and -4 minus 5 would be -9, and that would be the answer. If they wanted f of -3 itself, then you would look to see which one had the or equal to on it, okay? And so you would wind up plugging the -3 in there for the x, and only there. You wouldn't do it in both. And then that would be -6 minus 5, which is -11. And that would be the only answer to that one. And then -1 is actually to the right as well. I meant to pick one to the left. So let me make a -4 here. -4, which is going to be to the left of -3. So it's actually going to be smaller than -3. And let's find f of -4. Now here you got to be careful because you're putting the -4 in place of x. So you have to remember that that -4 needs to be in parentheses squared, so that if you're using your calculator, you're thinking the calculator is going to do what you say. So you got to be sure you're saying the correct thing. See, a -4 in parentheses squared is different. That's different than that. So watch it. We want -4 times -4, not the square of 4 is 16, and then you take its opposite. So put it in parentheses. That would be positive 16, and then -5 and -4 would multiply and be positive 20, and then we have plus 1, so we get 37 on that one. Okay? Right, another objective I wanted to do is to find and simplify a difference quotient. All right, so let's suppose that that our function, I'll make it an f of x, that our function was something like x squared minus 5x plus 1, just that. And we're trying to do a difference quotient. I'll do it. So find the difference quotient. Okay, they'll give you the formula for this. You won't have to memorize that, but you just need to know how to do it. It's all a matter of you understanding function notation. So the formula that they'll give you looks like this. Okay. And so then you've got to find f of x plus h. You're given, you already have f of x. You'll just need to find f of x plus h and then plug that into the formula in the correct spot, and then subtract what f of x is from it, and then divide by h and simplify. Folks typically mess up on this because really just not truly understanding function notation. A good way to do it is to find f of x plus h next. All right, so that means that x plus h is your new input. It's going in place of the x, okay? So it's up here, x was your input. So you had an x in those spots. If x plus h is your input, you need to replace those x's with x plus h. All right, now go ahead and work on simplifying this. So that x plus h squared is the source of many mistakes. That's really x plus h times itself. So when you FOIL that out, you're going to have two xh's in the middle. They're both positive, so you're going to get 2xh in the middle. So it doesn't turn out to be x squared plus h squared is the important thing. All right, I'm going to go ahead and distribute the negative 5 and add the 1. Okay, so I get to here. And there's no simplifying I can do at that point, but I haven't finished the question. The question wanted me to get the difference quotient. So that means I'm now going to plug x squared plus 2xh plus h squared, all this that we just found, goes in the top left in place of the f of x plus h in the formula. I'm going to subtract from that f of x, which is x squared minus 5x plus 1. Okay, so this first thing was my f of x plus h. Second thing was f of x. So this was the f of x plus h right here. All of that. And then this right here was the f of x. And then don't forget there's an h down there. All right, so then you work on simplifying that. So the first set of parentheses has an understood positive 1, so you really didn't even need those. But because of that minus sign, that's like a negative 1 out in front. So that negative 1 is going to need to get distributed. So it's going to change the signs, and you're going to wind up with negative x squared plus 5x minus 1. All of that still divided by h. So your x's are going to cancel. Your 1 and negative 1 would add up to be 0. And there's a negative x squared and a positive x squared. So we get a 2xh, an h squared, and a minus 5h that are left with an h below there. Okay. So because that's a single term, that h needs to be divided into each of those terms, or you could think of it, you can factor out the h if you want, like that, take out 1h and then cancel it out. So you can do that, or you could think h goes into 2xh, you'd have 2x left, h divided into h squared would leave you 1h, and h into minus 5h would leave you minus 5. So this would be finding and simplifying the difference quotient. All right, I also wanted to do the composition of two functions. All right, so let's suppose that we had one function, f of x, being 2x minus 5, and our other function being g of x being 3x maybe plus 1. And then what if you're asked to do the composition of the two? F, which is really f of g of x. Then what's important is that you understand that one function is going to be used as the input to the other one. In this case, see how g of x is going to be used as the input? So this is going to be put in place of the x in the f function, because that's what the function notation is telling you to do. G of x is 3x plus 1, and I need f of that. So that means I'm now going to use that as the input to my f function. So I'm going to do 2 times the 3x plus 1 and then subtract 5. And all that's left is cleaning that up. So I'm going to distribute the 2, 6x plus 2, subtract 5, and I'll have 6x minus 3. You don't get a number, you get it like a new formula. It's a way of creating new functions. Okay? So that was also chapter 2, and then there was one more objective I wanted to do, finding the inverse of a one-to-one function. So like if f of x equaled 2x minus 5, and I was asked to find f inverse of x, or find the inverse of that function. Here's what we did. We remembered that f of x really is just a y. Okay. Then we were able to interchange the x and the y variables. And when we do that, right there, I don't even need to, I'm not going to write it more simply. right there below that line, you actually have the equation of the inverse. We're just trying to get it in the correct form, okay? Back up a little bit. All right, so what I'm going to do from that point on is just rearrange things so that the y here is by itself. So people tend to do better if the variable you're solving for, the variable you want by itself, if it's on the left. So that's why I move things around. So now I can see I would need to add 5. So 2y is now equal to x plus 5. And then I'm going to come in and divide by 2. And so then I have that f inverse of x equals x plus 5 all divided by 2. So that's the idea of finding the inverse of a one-to-one function.